In this question, we have to prove the work done for a cycle which consists of two isothermal and two isobaric processes is minus P1 ln P1 upon P2 V2 minus V1, where V1 and V2 are the volumes and P1 and P2 are the pressure. So, first of all, we have to draw the PV diagram to solve this problem. On the vertical axis, the pressure is taken, and on the horizontal axis, V volume is taken. So, we can plot the PV diagram in this way. This cycle can be marked as the points A, B, C, D. Directions will be like this. This will be V1, this point will be V2, this point will be P1, and this point will be P2. A, B, and CD are the isothermal process, and AD and BC are the isobaric process. In the isobaric process, pressure remains constant. In the isothermal process, temperature remains constant. So for the cycle AB, we can write as PA VA is equal to PV VB. VB can be written as PA VA upon PB. In the terms of 1 and 2, we can rewrite it as P1 V1 upon P2. This can be written as equation number 1. So, in the same way, we can find out for the process T and D, which is again the isothermal process. We can write as VC is equal to PD VD upon PC, which will be in the terms of 1 and 2 P1 V2 upon P2. This will be equation number 2. Now work done for the isobaric process. In the isobaric process, pressure remains constant. W isobaric is equal to E Vf minus Vi, V final minus V initial, and the work done for the isothermal process nRT ln V final upon V initial. So according to the process, putting the values of volume and pressure and temperature. Now for the process AB, work done will be equal to nRT A ln VB upon VA. Putting the values, will get nRTA ln P1 V1 upon P2 into V1. V1 and V1 gets cancelled out. So it will be putting the value of nRT1 is equal to P1 V1 because PV is equal to nRT, ideal gas equation. So it will come out to in this form. Now work done for the process BC is equal to P Vf minus V initial P VB minus VC. Now putting the value of VB and VC, we'll get P1 V1 divided by P2 minus P1 V2 divided by P2. P2 is the common among all, and P1 we are taking out, so it will come out to be P1 V1 minus V2. Now work done for the process CD is equal to nRT ln Vd upon Vc, which we will get by solving P1 V2 ln P2 by P1. Now work done for the process dA. dA is the isobaric process. So this will be P1 VA minus VD, which can be further solved as P1 V1 minus V2. Now the net work done will be the summation of work done in each process. AB, BC, CD plus W, dA. Putting the values which we have calculated, P1 V1 ln P1 by P2 plus P1 V2 minus V1 plus P1 V2 ln P2 upon P1 plus P1 V1 minus V2. Now let's see what are the common values. How can we further solve it? This will be like this. It can be written as, we can take the negative sign out, so it will be V1 minus V2. Here if we reverse this, so it will be P1 V2 ln P1 upon P2. By taking the negative sign out, we can reverse the value which is inside the ln, plus P1 V1 minus V2. It's the positive value and it's the negative value, so we can cancel it out. Further, what will be left is P1 ln P1 upon P2 V1 minus V2, which will be minus P1 ln P1 upon P2 V2 minus V1. So net work done during the cycle is minus P1 ln P1 upon P2 V2 minus V1. This is the answer.